So what shapes, I'm not going to show you the drawing yet because I think it's probably, actually I know what I can do. What shapes are in a hemisphere? So remembering this is like our radius. What's there? Really bad drawing, sorry. There's a circle on the bottom. There's a circular base. And then what else is there? A circular base plus half a sphere. So what was the formula for a whole sphere? 4 pi r squared. So half of it, how many would it be? So this would be 2 pi r squared. And then how would we find the circular base, the area of a circular base? Area of a circle, which is? Okay, so if I've got pi r squared plus 2 pi r squared, what would my formula be? 3 pi r squared. So a hemisphere with a base is 3 pi r squared. A hemisphere without a base is 2 pi r squared. Okay, because it's half of the 4 pi r squared. So a whole hemisphere is 4. Hemisphere with a base is 3. Hemisphere without a base is 2. Everyone okay with that? Now again, I'll have to double check the formula sheet. I know there'll be some of them, but not all of them. So you've got a sphere, which is like a ball, okay? A hemisphere, which is half of one. The other types of shapes we've got are pyramids and cones, okay? So if we look at a cone, we're looking at a circle which goes up into a point. It has a height, it has a radius, and sometimes it has a slant length, which is this. If you don't have the slant length, what do you think you might need to do? You might need to figure it out. If you know the height here and you know the radius there, what angle does that make? A right angled triangle. And so you could use Pythagoras to find that slant height. And often we ask you to do that. Okay, so be aware that you might need to do that. So the height is the perpendicular height. So there's a couple of different formulas for this. You've got pi r times your slant length plus pi r squared is the official term. So pi times the radius times the slant length plus the circle at the bottom. So this bit here, the pi r times the slant length is actually the sort of the cone part, okay? And this part here is the circular base part. This is so you know that if you got asked to not include the base, you'd just take that pi r squared off. All right, so this, the yellow one, is this part here. The plus pi r squared is that base on the bottom. So if you actually got asked for the surface area of an ice cream cone, okay, you would just use the yellow part, that part, because it doesn't have a top on it. Everyone understand that? All right, so if you don't get given the slant height, we can actually do a formula which includes Pythagoras to work it out. So the way which we can do that is if we think about this. Now, I don't want you to write this all down yet. Okay, if you think about this, if we have 4 and a radius and a length here for Pythagoras, we could use Pythagoras to find this length. We'd be going length equals r squared plus height. Sorry, that's not 4, it's a height, plus height squared. Can you see how we'd square root the two shorter sides to find this? So because we know that, we can make up a formula which gives us the slant height. So instead of writing slant height or L, we can write the square root of r squared plus h squared. So this is our formula without the slant length. Total surface area equals pi r brackets square root of r squared plus h squared. This is the slant height, okay, hypotenuse, plus pi r squared. Can you write that bit down, please? Because that's the other one. So if you don't know the slant height, that's the formula you'd use. Because it's Pythagoras. So if you don't get told the slant height, you can work it out normally and then use the other formula as well. That's fine. But that's all. That working out normally is actually what's in the brackets. Okay, it's just up to you. Just be aware that you do need to know the slant height. All right, so for example, if we have this cone here, we've got 3 and 4, so you guys would know that the slant height is 5. Even though the question doesn't tell you, you can work that out. So therefore, if we then find the total surface area, now that we know that 5, we can say, we can use our formula, which is pi times the radius, which is 4, times the slant height, which is 5, plus pi times the radius, hang on, where's the height in here? There's not. Pi times the radius squared to work it out. So the 5 came from that slant height. So you don't actually need the actual height here for the surface area. You will need it when we do volume. Any questions about that? I think that is all the shapes. Just give me 2 seconds. Oh no, we've got to do pyramids. Let's get pyramids done. Sorry. I talked about them. I just forgot to actually picture. Everyone okay with them? So hemispheres, spheres, cones. Good? Has everyone finished writing? All right. Last one is pyramids. Okay, pyramids have a base shape connected with triangles. So pyramids are different to prisms. Prisms are connected with, have 2 base shapes connected with rectangles. A pyramid has 1 base shape, and then all of the edges have triangles which then come in together to make a pyramid. Okay? So they end up going into a point from those triangles. So a square, and then labelled by their base shape. A square-based pyramid has a square. How many triangles is it going to have? 4, because each of the sides of the square has to have a triangle attached which goes in together. Everyone okay with that? So therefore we have to look at a square. For this example, we've got 5 and 5. We've got the area of the square. Now the best way to do a pyramid is not even to look at a formula, is actually just break it down. Draw out the shapes, break it down. So the area of a square, how do I find the area of that square? 5 times 5, so we've got 25 square centimetres. And then we've got 4 triangles which are all the same because it's a square. Be aware if it was a rectangular based pyramid, they might not be the same, so just check it. So we've got 4 lots of that triangle. Now, the height of this pyramid is 5 centimetres here. But we're looking at this triangle here. The height of that triangle is not 5 centimetres. The height of that triangle is 6. Should have said centimetres there. Is 6 centimetres. So you need to be aware the height of the triangle might not be the same as the height of the actual pyramid, or probably smaller. So we have to look at it and go, okay, so we're saying half base times height. So half times 5 times 6, which is the same as saying half of 6 times 5, so 15. And then we're going to times it by 4 because there are 4 triangles there. So we've got 60. And so in total, we've got 25 plus 60. So we've got 85 square centimetres. And can you write with asterisks, remember to use the height of the triangle because that's where everybody gets tricked. So there's two different things. There's the height of the triangles and then there's the height of the pyramid. Now, you could have a hexagonal pyramid, which would have a hexagon on the bottom, which you could cut down into 2 trapeziums, and then you'd have 6 triangles coming up. Okay? You could have any shape as a prism as the bottom, and just remember that however many sides that shape has is how many triangles you're going to have coming up into a pyramid. Often, we'll only give you one of these questions in a test because they take a really long time. Okay, so just make sure you've really practiced, especially like a pyramid. All right, so if we just quickly, if we have a look at this square base pyramid, you could say b squared plus 2 lots of b times h because it's half base times height, but there's 4 of them, so it's 2 of them. That would work as long as it's a square base pyramid, if you wanted to. However, that's not on your formula sheet. I'd actually probably rather you just drew out the shapes, worked out the areas, than tried to rely on formulas, which you might get wrong. All right? Any questions? Okay, so you guys can now do, so we did question 8 last lesson, didn't we? So you guys can now do pretty much all of, all of exercise 9A, I think. Let me just double check though. Yeah, so let's go to, so you should have done to question 8 and question 11, so you should now be able to go to get question 16. So it's all of exercise 9A if you haven't finished the other questions. Yeah. So wherever you're up to, can you keep working through them?